Are you able to see the screen?
Yes.
So in the previous class, we did the haloform test, and haloform test will be given by only that of ketone which will have methyl ketone. Now, today's chemical reaction is a reaction due to alpha hydrogen. Due to alpha hydrogen. Now see what will happen. First of all, due to alpha hydrogen, so basically this alpha hydrogen is most acidic hydrogen in a compound. So I would like to write this acidity of alpha hydrogen. Acidity of alpha hydrogen of aldehydes and ketones. And I will show you why these alpha hydrogens are most acidic other than other hydrogens. So as you know that, just wait a minute. Okay. Now, as you can see, this is your either ketonic group or aldehyde, and the carbon which is directly connected to this carbonyl group is called alpha carbon, and the hydrogen which is connected with this carbon is called alpha hydrogen. So this is your alpha hydrogen. Now see what will happen. Since it is alpha hydrogen, so its electron will be taken by carbon, and hydrogen will be released in the form of H plus, and hydrogen will be released in the form of H plus. Now as you can see, this is your C double bond O. As it is, there is a bond, and then this is the bond. Now carbon has negative charge, and as you know that this is in conjugation, pi sigma negative charge, so it can move in this way. So it will be CO negative, and then there will be double bond C like this. Are you getting my point? So due to this alpha hydrogen in a carbonyl group, if it is group, it goes out. H plus hydrogen becomes H plus. So this negative charge will be in conjugation with the double bond, and due to this double bond and conjugation, there will be resonance. That's why it is stable. That means if this conjugate base is more stable, that means it is most acidic. Is that clear, Firaz?
Yeah.
So can I change the slide?
Yes.
No. Now, in this, we have a small topic which is quite important, and that is from this chapter, that is your aldol condensation. Aldol condensation. And what is aldol condensation? So first I'm going to write all the theories, okay, and then I will explain. Okay, so write with me. And this reaction, the aldol condensation, only will take place with that aldehyde and ketones which will have alpha hydrogen, So what I'm going to write with me. Aldehydes and ketones having at least one alpha hydrogen, at least one alpha hydrogen undergo a reaction in the presence of dilute alkali. In the presence of dilute alkali, that means base. Basically, you can take NaOH or KOH, dilute alkali, as catalyst. we will use this dilute alkali as catalyst to form beta hydroxyaldehyde. To form beta hydroxyaldehydes, that means basically beta hydroxyaldehyde, that means it is aldehyde, so we will use ald, and it is hydroxy, that means alcohol, we will use all. So it is also known as aldol if it is aldehyde. Or there will be formation of beta hydroxyketone if the compound is ketone, beta hydroxyketone, and that is known as ketone. That is known as ketone. Is my video lagging?
I'm not seeing the video, sir. Seeing the screen. Your audio is fine.
Okay. Okay, audio is fine. Then I just turned off my video. No problem, because it was lagging here. So aldehydes or ketones, so respectively. Just write with me. Then I'll explain all this. And this is known as aldol reaction. This is known as aldol reaction. Please do write with me. And here is a key point, which is aldol for aldol condensation, and that is basically the aldol and ketone readily lose water to give alpha beta alpha beta unsaturated carbonyl compounds, which are aldol condensation product, which are aldol condensation product, which are aldol condensation product. And the reaction is known as aldol condensation. And here we can write the reaction is known as aldol condensation. So please do let me know when you are done with this. It's the reaction is very easy. First I will explain this, then I will take example, and then I will again explain that. Are you done with this? Firaz?
No, sir. 1 minute.
Okay.
Done. Sir.
Very good. So now see what you need to do. First, when you are going to do aldol condensation of any this aldehyde or ketone, first you need to see whether there is at least one alpha hydrogen or not. If there is no alpha hydrogen, then that means aldol condensation will not take place. Now, the next point, which is quite important, if you have an aldehyde or ketone which is having an alpha hydrogen, so you are going to treat that with alkali. Alkali, that means dilute alkali, that is basically NaOH or KOH. Okay, so can you tell me whether this reaction will take place or not? HCOOH, whether this will show aldol condensation or not?
No.
No, because you can see this is C double bond OH, and there is no alpha carbon directly hydrogen connected, no alpha carbon, that says no alpha hydrogen, zero alpha hydrogen. Okay.
Yeah.
Wait a minute. So Firaz, now I'm going to take ethanol, and this is your ethanol. This is your ethanol. Will this compound show aldol condensation? Yes or no?
Yes.
Yes, because it has alpha hydrogen. It is having alpha hydrogen. So can I represent this as this CHO? And you are going to react this with a catalyst, that is dilute NaOH. Now, what you have to do, you know, this is alpha hydrogen. If this is your alpha hydrogen, so it will be released. That means H plus will be given, right? So it will become CH2 negative CHO. Yes or no? Please do
Yeah.
that. Now, again, you have to take 1 mole. For aldol, you need to take 2 moles of this aldehyde. So now you are going to take another mole of aldehyde. Okay. Actually, the concept is that you need to make one of the aldehyde as nucleophile. This is nucleophile or not? Yes or no? Firaz, do you know nucleophile?
Yeah.
So this is your nucleophile acting as nucleophile because it is electron rich species, because carbon has negative charge. And one of the aldehyde, you are going to make it the electrophile. How? Oxygen will take electron from carbon, so there will be deficiency of electron on this carbon. Yes or no? Please do let me know.
Yeah.
So this carbon is having rich in electron. That means basically it will attack on this carbon. Okay. So I'm going to write this part first. So as you can see, this will be CH3, then CO negative, and this carbon is connected with this hydrogen. So I'm going to write it together. And this CH2 directly attacked on this. So it will be CH2 and then CH. Yes or no?
Yeah.
Are you getting? And after this, you are going to hydrolyze it. That means H plus and OH minus will be there. So it will be attacking here, and you will be getting the product of aldol reaction, CHOH, and this is your CH2, and this is your CHO. As you know that, this part is basically your main functional group. That this means alpha carbon, and this that means beta carbon. Yes or no? Alpha or beta? Are you getting my point? Alpha carbon, beta carbon.
Yeah.
And beta, with beta carbon, OH is connected. That's why it is known as beta hydroxy. Beta hydroxy. And this is your aldehyde. Beta hydroxy aldehyde. Or we can write aldehyde, ald for aldehyde, all for alcohol. So this reaction is also known as beta hydroxy. This product is also known as beta hydroxyaldehyde or aldol, or the reaction is known as aldol reaction. Are you getting my point? Yes or no?
Yeah.
So this is the only aldol reaction. We need to do further for aldol condensation. Before that, I would like you to write all this and then let me know. Then I will go for the final step. Let me know when you are done with this.
That's a
Very good. So Firaz, you can see this is your aldol reaction. And for aldol condensation, that means you are going to remove water. Are you getting my point? This is the condensation. Yes or no?
yeah.
So always remove OH from beta carbon, and hydrogen from alpha carbon. Alpha hydrogen you are going to remove, and beta OH you are going to remove. You can remove hydrogen from here as well, but that will not be the major product. It will be minor product. And generally, in question, it will be asked to write the product, that means the major product. So if you are going to remove this OH, and one of the hydrogen from the alpha carbon, there will be double bond between this carbon and this carbon. So what will be the product? The product will be CH3 CH double bond CH and then CHO. And as you can see, this is your aldol condensation. And isn't it unsaturated? This is your alpha, this is your beta. So the product we can write alpha beta unsaturated aldehyde. Are you getting my point?
Yeah.
And if it comes from ketone, then it will be beta hydroxy ketone and the name will be ketone. And here it will be alpha beta unsaturated ketone. So it's quite easy and very, very easy, I think, right? Right.
Yeah.
Let me know when you're done with this. Let me know when you're done with this. Let me know when you're done with this.
Done, sir.
Okay, so again, I'm going to explain this. If you are going to do the aldol of any aldehyde or ketone, so what you need to do, just in the first step, you are going to remove alpha hydrogen. So there will be negative charge on one of the carbon from on alpha carbon, basically on alpha carbon. Now, the next point is basically you are going to take another mole of this aldehyde and you are going to make it a electrophilic center on the carbon. Are you getting my point? This carbon, which is connected to the oxygen doubly bonded. Okay. After this, you can see there is a electron rich species or electron rich site, nucleophilic center, and there is electrophilic center. So just attack on that. And then you are going to mix it and you will be getting like this. And after this, you are going to hydrolyze it, H2O. So H plus will be attacking on the O negative and you will be getting beta hydroxy aldehyde, which is known as aldol. After this, you need to remove H2O and H2O. Always remember that OH from OH will always be on beta. And you are going to remove hydrogen from alpha, not on from gamma, not from gamma. This is your gamma, not from gamma. So there will be double bond between alpha and beta carbon, and then aldehyde will be there. And if it is ketone, then there will be ketone. Are you getting my point?
Yeah.
So what you need to take care if ketone is given, so do the same step. Like you need to remove the alpha hydrogen, then do this part, then attach them together, then react with H2O so that H plus will be formed. So this is the concept behind it, and I want you to do this. And you have to take 2 moles of each. Okay. So if I'm going to give you CH3, CH2, CH, just do the aldol or aldol condensation and let me know the product. I think you can do the you can name this compound, right? What is the IUPAC name of this compound? This is 1, 2, 3, 4. So it will be but 2 1 al, and here it will be 1, 2, 3, 4. So it will be 3 hydroxy, and it is butanol, right?
Yeah.
So you are going to do the aldol of this and let me know the answer, final answer. 2 products like this, aldol product and aldol condensation product. So this is your aldol condensation. Can you do it? Please do.
So CH3 will become CH2, and that hydrogen becomes OH.
CH3 becomes CH2. Are you talking about this CH3?
Yeah.
No, it's wrong. You need to remove alpha hydrogen, no? See, I'm going to give you. I'm going to explain.
Oh, CH2 becomes CH.
Yeah,
Yeah.
it will be not CH, this will be basically negative, right?
Yeah.
So you should do it on your own. And then again, you are going to take positive, and then again going to take another mole of this. So CH2, then double bond O, like this, right? So it will be going like this. So this will attack on this carbon, right? Yes or no?
Yeah.
So I'm going to write this part first. So this part can be written as you can see, this is your CH3, then CH2, and then there will be
CH.
CO negative CH. And you can see this CH is directly connected, will be connected to this CH. So there will be CH. And with this CH, there is CH3 on the left, which I'm going to write on the bottom. And this, there is CHO on the right hand side. So I'm going to put it here. Are you getting my point?
Yeah.
Yes or no? And if you're going to react this with H2, that means H plus is directly going to attack on this part, and you will be getting the aldol product CH3, CH2, CH, OH, and then there will be CH, and then there will be CH3, and then there will be CH. And for this is your aldol reaction. And if you want to write, you can see this is your alpha, this is your beta. So this is your beta hydroxy aldehyde. This is your beta hydroxy aldehyde. That means basically aldol it is. And if you are going to do the aldol condensation, removing H2O, so OH from beta and hydrogen from alpha. Alpha carbon is this. So there will be double bond between alpha and beta carbon, and the product is basically CH3, CH2, and then it can become CH double bond C, and there is CH3, and then there is CH. Now, please write the IUPAC name of this. Let me know, and this as well. Let me know when you are done with this. Just let me know when you are done with this.
Yeah, done.
Very good. So now I'm going to give you another. Oh, I gave you to write the name, IUPAC name of this, right?
Yeah.
So what is the name? 2-methyl
butane 2
bute 2 in 1-al, right?
1-al. Yeah.
Okay. Very good. Wait a minute, please. Yeah, what is the name of this one? What is the name of this one? This will be 1, 2, 3, 4, 5. So the name will be 2-methyl, and before 2-methyl, there will be 3-hydroxy, 3-hydroxy 2-methyl pentanal. Oh, pentanal. 1, 2, 3, 4, 5. How many carbon here? 1, 2, 3, 4, 5. Okay. So it will not be bute. It will be pent 2 in 1-al. Is that clear? Firaz,
Yes, sir.
got it?
Yeah.
Can I change the slide?
Yes.
Okay, I'm going to give you the ketonic wall, ketonic part. This is your CH3, C double bond O, CH3. So please do this aldol reaction. Dilute NaOH or KOH you can take. Can you do this? Firoz, will you be able to solve it?
Yeah.
Okay.
CH3C.
Yeah, please do solve all them. Let me know.
So CH3 then CH3 then square root. CH2 and then C and then C.
Why are you telling me only about CH2? It will be CH2 negative now.
Yeah. And then C and CH3 and OH will be branched. Then CH3. So pentane, 4-methyl pentane 2.
Let me check it. See, first of all, you need to see this is your functional group. So this will be your alpha carbon and this will be your alpha carbon. Now I'm going to show you. This is CH3 C double bond O and this is your CH2H, right? Now you can see this is your alpha hydrogen, so it will be converted into CH2 negative. So it becomes CH2 negative, and then there will be C double bond O, and then there will be CH3. Now you are going to take another mole of this, and it will become CH3 C double bond O and CH3. Now what you need to do, just remove this, so it will attack on this. So I'm going to write this part first. So here it will be CH3CO negative, and there is CH3 that I'm going to write it downward. And then this CH2 will be connected to this, so it will be like CH2. And after this, there is C double bond O, and after C double bond O, this is CH3. So it will be like this, right? So this compound will be hydrolyzed H2O, and H plus will be directly attacking on the O negative, and you will be getting CH3 COH, and then CH3, and then CH2, and then C double bond O, and then CH3. Now, as you can see, this is your alpha carbon and this is your beta carbon. That means beta hydroxy. This is your beta hydroxy because alcohol, and this ketone. So beta hydroxy ketone, which is known as ketol, and the reaction is known as ketol reaction. Ketol. Are you getting my point? This is what you have got.
Yeah.
Yeah. After this, you need to do the condensation. That means you are going to remove water. So H2O, again the same concept. OH from beta and H from alpha. So there will be double bond between this and this. One of the hydrogen will be removed also. So this will be CH3, and then it becomes double bond and becomes CH, and then C double bond O, and then CH. Are you getting my point? So what is the name of this? 1, 2, 3, 4, 5, and the name of this 1, 2, 3, 4, 5.
For methyl, no, for hydroxy, for methyl.
Oh, what you just, yeah, that's good. 4-hydroxy, 4-methyl.
Pentane to 1.
That's good. Pentane to 1. Very good. What about this?
For methyl, pentane.
What you just said, 4-methyl pent.
For pent 3N.
Very good. 4-methyl pent 3N 2-on. Very good. So I think you are I think you are done with this. Like, do you have any doubt in this? Yes or no?
No.
Now, see. Now it's very important. What is the concept behind it? What you are going to do, take one mole and make it nucleophile, right? This is the concept. And take another mole, make it electrophile, and then react it, right? Then fuse it. Firaz.
Yeah.
Now we are going to do cross aldol. Cross aldol or cross ketol is very easy reaction. Cross aldol condensation. This is in our syllabus, and cross ketol condensation. You can also do that. Okay. See what you need to do. In the previous question, we had taken same mole of both. Have you seen? Like I had taken only propanol, 2 mole of propanol. Before this, 2 mole of propanol. Before this, 2 mole of ethanol. What is cross aldol condensation? So basically, 2 mole of other aldehydes or ketones. Like if you are going to take CH3 CHO going to react with ethanol, going to react with propanol. Are you getting my point? In the presence of dilute NaOH, this will be the cross aldol. Is that clear?
Yeah.
Now see, it's very easy. As you can see, what you need to do, whenever you are going to do cross aldol, there will be four products. There will be four products. How you will get four products? So basically, there will be one product by this itself. CH3 CHO will be 2 moles of each other, and you will be getting an aldol product from this aldol condensation product. Are you getting my point? Yes or no? Firaz.
Yeah.
And this is propanol. It will also react with itself to make a product. That means we get two products, and we have already done about this. To this, you can see the aldol condensation of propanol. We have got this product, and aldol condensation of ethanol, as well as we had this product. Got it? Now see, there will be cross. Already, are you confident about the two products that I just discussed? Yes or no?
Yeah. Ketol and
No ketol.
aldol.
Why are you talking about ketol? I am talking about, this is your we are going to do cross aldol. Firas, cross aldol. Cross aldol, that means different aldehyde. Previous one was aldol condensation, in which same molecule of aldehyde or same molecule of ketone reacted with each other, like ethanol ethanol, propanol propanol, propanon propanon. But in cross aldol we have ethanol and propanol. Okay, this is your cross aldol condensation, and here we have four products. We will have four products. Got it?
Yeah.
Now see, what I want to tell you is that this ethanol will react in itself and give one product, that is aldol condensation, normal aldol condensation. It will have 2 moles of ethanol and it will give one product. Again, this propanol will react itself and give one product. Are you getting my point? So two products out of these four products, we get two products, normal aldol condensation. Got it?
Yeah.
Now see, the third product, how I am going to do it. The third product, first I'm going to do, this is your CH2 and this is your H, and then this is your CH. So what you are going to do, you are going to react this with dilute NaOH, and as you can see, this is your alpha hydrogen. So I'm going to make this ethanol, nucleophile. So it will be CH2 negative and this will be CH. Now the another propanol that I'm going to take, I'm going to make it electrophilic center. There will be electrophilic center here. How it will be created, you can see this will be like this. So this carbon will be attacking on this. Are you getting my point? So this part I am going to write it first. It will be CH3 CH2 and then CO negative. Hydrogen is there, and then CH2 is connected with this, and then comes CH. After this, you are going to do the hydrolysis. H plus, that will be directly attacking on this. So you will be getting CH3 CH2, and then you will be getting CHOH, and this is your CH2CH. Beta hydroxyaldehyde, this is. Now after this, you are going to do the aldol condensation, that means removal of H2O. H2O, that means you are going to remove hydroxide from here and one of the hydrogen from here. So what will be the product? CH3 CH2, and then there will be CH, and then double bond, then CH, and then CH. Got it? Yes or no? So this is the third product.
Yeah.
This is the third product. Now see, what I have done in the third product is I took this ethanol as nucleophile. I made it nucleophile and this propanol propanol as electrophile. For the fourth product, you are going to make this nucleophile and this as electrophile. Can you do this? Can you do this? Firaz, can you do the next part? Fourth product. Firaz, are you done with this?
Yeah.
So what is the product you have got for the fourth product? Are you solving it or you were solving writing this?
Pen to enal.
Pen to enal. Just let me check it. You have this CH3, CH2, and this is your CH. Okay, so you made a nucleophile, dilute NaOH, nucleophile, it becomes nucleophile and it will be like CH3, CH negative CHO, and you took ethanol and make it, there will be an electrophilic center at this. Will be like this and this will be attacking on this. So I'm going to write this first. So it will be CH3, CO negative and H is there and this CH will be directly connected to this. On the right hand side there is CHO and on the left hand side of this CH there is CH. So after this you are going to do the hydrolysis in which H plus will be attacking on O negative from where beta hydroxy will be formed. So this will be CH3 CH OH and then there will be CH and then there will be CHO and there is CH. And after this you are going to do the aldol condensation, cross aldol condensation it is. So H from here and hydrogen from here will be removed and this will be CH3 CH double bond C and there is CHO and there is CH3 that I am going to write on top. Now if you are going to write do the numbering 1 2 3 4, so the name will be 2-methyl and then comes bute 2-ene 1-al. This is the answer that you have got or something else. Is this the answer?
But two products are formed, right?
Two products? What do you mean by two products? Yeah, one is here. This is aldol, and this is your aldol condensation product. We only talk about this after removing water, condensation after removing water. Are you getting my point?
Yeah.
So we have four products. First one is this, in which double bond comes, and the second one is this, and before this there will be aldol condensation of this ethanol and then propanol. So we have four products. Got it?
Yeah. That's what I was talking about. Pentane to enol, other product.
Pentane to enol.
No, not this one, the other one.
Oh, I was talking about this.
Yeah, this is 2-methyl bute 2 in L.
One. Okay. So are you done with this? Can I change the slide?
Yeah, I wrote.
And it's also very easy if you are going to do it like this. Just let's take another example of reaction, that is other other reaction. And do you have any doubt in aldol or aldol condensation? Yes or no?
We can like solve more questions will be good.
I'll be giving for homework. Will it be okay?
Yeah, okay.
Yeah, because it will consume our more of the time in this. If you want to do, I can give you. Please do the. If you want to do, please do the aldol condensation of butanol. Will you do it right now or at homework?
Later.
Later. So do the aldol condensation of this. Okay. And also this is the first part, and do the cross aldol of butanol with propanol. Okay, aldol. Now see, Cannizzaro reaction, and this reaction is basically takes place where no alpha hydrogen is present. So I'm going to write a point about this. Please do write with me. Aldehydes which do not have an alpha hydrogen, which do not have an alpha hydrogen atom, undergo self-oxidation and reduction with Firaz, let me know when you are done with this. Let me know when you are done with this. Okay.
Yeah, okay, sir.
Done.
Yeah.
Okay. So it's very easy. First of all, Cannizzaro reaction will only take place when there will be no alpha hydrogen. First of all, there will be no alpha hydrogen if Cannizzaro reaction is going to take place. Now, how the reaction will take place? Like this is your methanol, which has no alpha hydrogen. So you are going to take again 2 mole of an aldehyde or ketone which has no alpha hydrogen, and you are going to react this with concentrated KOH, and then you are going to give heat to this. So one of the aldehyde will be converted into alcohol. So this will be converted into alcohol CH2H, and one of the aldehyde will be converted into carboxylic acid salt. So this is your carboxylic acid, and you are going to remove one hydrogen and put it this metal, whatever is the metal Na or K, and it will be carboxylic acid salt. So it is known as disproportionation reaction. You have studied it in class 11 that uh, when same reactant or same element or group oxidized or reduced simultaneously, that is known as disproportionation reaction. So this is your aldehyde, this is your aldehyde. One is reduced to alcohol, one is oxidized to carboxylic acid salt. So that's why it is disproportionation reaction. Okay, is that clear?
Yeah.
Firaz, so I will be out for a while. So please do this question. Butanol plus propanol. I'm coming from Boston. Propanol. This is your uh, question for right now, and then you are going to do the uh, pentanol plus butanol. This is for aldol and aldol condenses. Got it?
Aldol and cross aldol.
Yeah, these both are aldol. All the 4 products, 4 for this and 4 for this, you need to do. And you also need to send me. I want to see how you are solving it. Okay. You have 15 minutes. And don't leave the meeting, please. Is that clear, Firaz?
That is a CH3OH, right? Not CH2.
Yeah, sorry. It will be CH3OH. It is methane. Thank you. And this is your carboxylic acid. So will you be able to solve it?
Yes, sir.
Okay, thank you. Firaz, Firaz, am I audible?
Yeah, sir.
Okay. Are you able to solve it? The first one,
No, sir, I didn't solve it.
you didn't solve it. Second one,
No, I'm doing first one.
okay. How much time you, how many products you have calculated out of 4?
Two methyl bute, two in one L.
Okay, okay. No, Firaz, you are going to send both the after solving this to WhatsApp. Okay, I'll check it there.
Okay.
Okay, I just want to see how you solved it. So if you are in hurry right now, so next year you are going to write every steps. Okay.
Yeah.
Okay. Have you got the Cannizzaro reaction? Cannizzaro reaction only takes place with aldehyde and ketones having no alpha hydrogen. And one of the aldehyde, basically this only one aldehyde will be there, will be reduced to alcohol, and another will be oxidized to carboxylate carboxylic acid salt. Now I want to give you NCERT question. Please do let me know the product. This is your aldehyde, and also this is your wait a minute. Okay, and you are going to do the reaction with concentrated HNOH and heat. Then let me know the product. Are you able to solve it, Firaz? So this will be reduced to alcohol. How it can be reduced? So I'll show you here. It's very easy. So this is your C double bond OH. So you are going to break one of the bond between carbon carbon. It will be hydrogen and hydrogen. Now, if you are going to reduce this to alcohol, so what it becomes? CH2OH. And if you are going to oxidize to carboxylic acid salt, so this will be your carboxylic acid, but you need to make a salt. So just replace this. This is your carboxylic acid. So just replace this hydrogen with Na, and you will get the product. So these are both the products that you need to take care. Okay. Is that clear? Firas?
Yes. Yes.
Okay. Can you change the slide? The last reaction of aldehyde and ketones we are going to do, that is electrophilic substitution reaction. Electrophilic substitution reaction. So this is your benzaldehyde. And if you are going to react this with HNO3 in the presence of H2SO4 at 273 to 283 Kelvin. So this NO2 nitration will take place and NO2 will go at meta. NO2 will go at meta. Okay, not at ortho and para, because this CHO is having minus R effect. This CHO is having minus M or minus R effect, and you know that minus M, that means it will withdraw electron from benzene ring, and there will be positive sign, there will be positive sign, and there will be positive sign. And NO2 is a electrophile. NO2 plus is electrophile. That means it will attack at that site where electron rich species are available, where nucleophilic center is there. So you can see positive sign, positive sign, positive sign. It is electrophilic center, and it is already electrophile. So it will attack on matter, because at least it doesn't have positive charge. That's why NO2, this is meta directing group. Okay.
Yeah. Okay.
This not NO2, basically this CHO is acting as meta directing. Got it?
Yeah.
Can I change the slide? Please do write it and then let me know. Let me know when you're done with this. Are you done with this, Firaz?
Yeah.
Okay, Firaz, so see, in the next class, we are going to start carboxylic acid. We are going to start carboxylic acids. So in this, you are going to cover the nomenclature. I think, are you free for 10 to 15 minutes more, 10 minutes more? Or you
Yes,
have
sir.
any other class? Okay. So I was thinking to discuss the nomenclature only. So nomenclature, you know, it's IUPAC is like alkane plus oic acid, alkanoic acid, alkanoic acid.
Yeah.
If you have HCOOH, if you recognize the functional group, that is carboxylic acid, and only one carbon is there, so its name will be methanoic acid. Its name will be methanoic acid. And if you have like this, so two carbon, its name is ethanoic acid, right?
Yeah.
And then it comes like if you have like this COOH and there is a ketonic group. So you can see this is the most senior functional group. So we will give priority to this carboxylic acid. And every other functional group will be treated as substituent. So its name will be 2-oxo and then pentanoic acid. Then pentanoic acid. In case if you are unable to count the number of carbon of carboxylic acid, like if you are unable to count the number of carbon in parent chain of carboxylic acid, then its name will be ending with carboxylic acid. Like this is benzene and I'm not counting this carbon, so its name will be benzene carboxylic acid. Benzene carboxylic acid. Is that clear?
Yeah.
Its name is basically benzoic acid. Its common name was benzoic acid, but now it is treated as IUPAC, the benzoic acid. Now the next, if you have a structure like this, COOH and COOH, and if you are not counting, there is two types of nomenclature you can do, 1, 2, 3, 4, and you can see it has 4 carbon in parent butane, 1, 2 dioic acid, dioic acid. Are you getting my point?
Yeah.
And if you have like this, the structure is like this, COOH, COOH, and then COOH. And if you are going to count the number from here, 1, 2, 3, 4, 5. So you can see this carbon is not counted. So what I'm going to do, I'm just going to leave all the carbons of carboxylic acid like this, and I'm going to number it from 1 to 3. Now its name will be propane 1, 2, 3 tricarboxylic acid. Tricarboxylic acid. Is that clear? Is that clear, Firaz?
Yeah.
So if you want to write it, you can. We will start from the preparation of carboxylic acid in the next case. Are you free on Sunday? Firaz?
Yeah, I'm free, sir, but maths, I think they said